Okay, today we're going to talk about circular functions. We've kind of already touched on this. I mentioned that the points are going to be on this circle in the form, I keep doing that, cosine theta, sine theta. So what you want to remember is if you're given a point on the terminal side of theta, the cosine is the x value and the sine is the y value. Now, that doesn't say that it's not x over r. You know how we talked about cosine x over r, sine y over r, etc. Well, we're just having a radius of 1. That's why it's cosine is x and sine is y, because if you put these over 1, it's not going to change anything. Okay, so the points here are giving you the x, which is the cosine, and the sine values. That's about all you need to know there. That's all this thing says. So, oh, that's the unit circle that we've developed. That one looks awful compared to, I think, what we already did. I'm just jumping over a couple of things here and getting to, I don't know why this is written on, but anyway, this is an example that all it's doing is telling you that the terminal side of the angle theta in standard position intersects the unit circle at the, and it says unit circle. So this has to be in a unit circle for this to be true, because that's when r is 1. Bless you. Okay, so if you're given the point, then the cosine is the first part. So cosine of theta would have been negative 5/6. Sine of theta would have been square root of 11 over 6. Okay, so what's the cosine? Cosine of theta, and you need to write theta. It would be the first part, the x part, negative square root of 3 over 2. And the sine of theta is the 1/2. Number 2, the cosine of theta is 0. The sine of theta would be negative 1. And it did just ask for cosine and sine. We could find the other trig functions off of these as well. Number 3, cosine theta. It's almost like, why are we writing so many of these examples? Because they're so simple, right? Sine of theta is square root of 5 over 3. Now, you could tell what quadrant you're in. This would have been quadrant 2. The first one would have been also quadrant 2. You want to know where that point was terminating. 0, negative 1, where's that? We actually already know where it is. 270, yeah, that's like 270 degrees, or 3 pi over 2. Okay, good to kind of think about that for a minute. I don't know these because these aren't on our unit circle. So I couldn't tell you what those are off the top of my head, but I could tell you where I am. This point would be terminating in quadrant 3 because it's negative, negative. Okay? But the cosine of this answer, whatever theta is, I did not bother to figure that angle out. The cosine of theta equals negative 4/5. And the sine of theta is negative square root of 3 over 5. Okay, now it says P is on the terminal side of theta equals 45 degrees. We should know where that is, of course. That's quadrant 1. If that's 45 degrees, you could use special right triangles to figure these out, unless you have them memorized already that the sine and the cosine are both, for 45, square root of 2 over 2. And I will refresh your memory on how to get that off special triangles. So, cosine 45, square root of 2 over 2. Sine 45, square root of 2 over 2. Oops. Okay, if you're thinking about special right triangles and the radius is 1, then this vertical number, the y value would be 1 as well, and the hypotenuse would be the square root of 2. So there you can see opposite over hypotenuse, 1 over the square root of 2 rationalized, because your answers need to be rationalized. That's where I'm getting square root of 2 over 2. Sine and sine are both the same for 45. Now, P is on the terminal side of 120 degrees. I'm going to go ahead and sketch where that is. What would the reference angle be? Yeah, because this is your 120. The reference angle is always the angle with the x-axis, so that would be 60. You could think of special right triangles. That's 30, 60, 90. This would be negative 1 for the x value. square root of 3 for the y value, and the hypotenuse would be 2. So if you're trying to find, well, what did it ask us to do? Are we still finding sine and cosine of these? Okay, so if we want to know the sine and cosine, the cosine of 120, that's what we're finding. I'm using the angles. I'm not writing theta because we actually know the angle measure. The cosine of 120 would be adjacent over hypotenuse would be negative 1/2. Sine at 120 would equal opposite over hypotenuse, square root of 3 over 2. Cosine is negative in quadrant 2, sine is positive in quadrant 2. I'm just jotting down what quadrant I'm in. Number 7, 240 is going to land us in quadrant 3. Okay, so I always want to know where you are. So quadrant 3, that's going to tell me something that the sine and the cosine are both negative. So cosine 240 I'm going to figure out, and the sine of 240. So if you want to think how far into this quadrant am I from 180, that would be 60 degrees in. So I got another reference of 60 degrees, just like the last question. So since I already figured out the last question, these answers are going to be the same, except they're both negative. So negative 1/2 and negative square root of 3 over 2. Okay, now P is on the terminal left side of theta is 330. 330 degrees puts me into quadrant 4. Okay, how far down from 360 am I? Yep, 30 degrees. So your reference angle would be 30 degrees. In radians, that's pi over 6. All right, didn't ask us for radians though. So cosine of 330 degrees and sine of 330. Hopefully we've got it straightened out that if you know this, well, that the cosine, and memorize this one would be nice. Cosine of 30 degrees, square root of 3 over 2, sine 30 degrees is 1/2. And so if you have that memorized, then these are both the same, square root of 3 over 2 and 1/2, except we have to decide their sign, meaning positive or negative. The cosine would be positive because x is positive, and the sine would be negative because, and I could do the special right triangles again, this would be negative 1, this would be the square root of 3, this would be 2. So negative 1/2 is the sine of 330. Okay, anybody still need this? Or any questions about this right now? Yes? Plotting points. What quadrant you're in. Of x is positive, y is positive in quadrant 1. Okay, now you remember, okay, quadrant 2, x is negative, y is positive. Quadrant 3, I might as well finish in case someone else was thinking the same thing. They're both negative. Looks like a face. Okay, in quadrant 4, the x value, oops, that's a Q. Quadrant 4, the x value is positive, the y value is negative. So cosine is x, sine is y. It follows that those would be the same sign as those quadrants. Yes? Oh, yeah, you can never do it here. No, 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 no. That's a huge no-no. Because I have said this a bunch of times, and we need to talk about that if we're not remembering that. What did I tell you the reference angles were made with? Okay, you see what I'm remembering now? All right, so you remember what I was telling you? You want to think only of your bow tie. Okay, so you've got to remember that the reference angles are here. Always with the x-axis, never with the y-axis. And they're themselves in quadrant 1. Okay? All right, good. Definitely need to get that straight. That's very important. Okay, so on the back page of this, it's a fairly short lesson today. We're going to talk about periodic functions. A periodic function is a function that has a pattern. It repeats on regular intervals. So, a periodic function has y values that repeat at regular intervals. One complete pattern is called a cycle. So definitely need to know what a cycle is. The way we're going to talk about it is the length of one cycle is called the period of the function. The sine and cosine functions are periodic, and each has a period of 360 or 2 pi radians. So think about our unit circle. You know how you got all those answers that repeat within that unit circle? Okay, so you've got yours, I'll just even do references of 30, that's square root of 3 over 2, 1/2. So the cosine of 30 is square root of 3 over 2, the sine of 30 is 1/2. Well, the reference angles in this quadrant, it's the negative square root of 3 over 2, 1/2. In quadrant, the reference of 30 in this, they're both negative, sine and cosine, and in this quadrant, it's positive for the cosine and negative for the sine. All right, so with that in mind, none of these points is really repeated. See what I'm saying? They're all different. They have the same values, but something is different about every one of those points. They're different locations. So the pattern doesn't repeat until you start doing angles that are coterminal. Okay, so we'll go back around. So one cycle of the sine or cosine, every time it's changing around the circle, it's going to repeat after 2 pi radians. Oh, back to that problem right here. What's the period of this weird graph? I mean, I have no idea what the equation of that is actually, but you see that it's doing one pointy part and then a curvy part, and then it repeats the pattern. So the period here is 10. That's why. Because that's when it starts to repeat itself. When I look at number 9, what is the period of this function? So we're going to write period is, and then we're going to say, okay, I go flat, and then I go up, then I come down, then I go up, then I come down, and then the first new flat part starts right here. So the period, I need to figure out what it is from 0 to here. I need to count it. Pardon me? Okay, you 2.5 pi, but I would kind of prefer that you got used to doing them in fractions, but that's not wrong. Okay, 2.5 pi isn't incorrect, but let me show you how to count it because you're going to be graphing trig functions. We're going to actually start looking at them tomorrow. I'm going to show you what they look like, and you're going to need to be able to label the axes accurately. So 2.5 pi, if you wanted to count it out in terms of pi, if this is pi, what's this? Halfway between it, that's pi over 2. Now I'm going to count by, you see how the spacing is pi over 2 units? That's called the scale of the x-axis. So if you went 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2, 4 pi over 2 is 2 pi, 5 pi over 2. So 5 pi over 2 is the period, which is equivalent to 2.5 pi. Okay? So I want you to learn how to count like that because that's going to help you with graphing and help you with labeling the axes appropriately and naming the points on the graphs. So we're going to be naming things like, where is pi? Is this value right here? That would be at pi 1. Not that I'm asking you that right now, but that's where it is. Okay? The x value is pi, the y value is 1. On number 10, we see it's just a kind of a V graph, and then it's going to repeat itself, another V here. So where it started to repeat was right there. So the period is 6. Okay, 11, the period would be every 4, so it's 4. Okay. Number 12, what's happening on that one? Well, you got a flat part, go down, go over, go up, and then you start over. So that's the period of 2. And 13, the period is 2 pi. And that happens to be y equals the sine of theta. Okay, we're going to learn how to graph that and label all the x-axis and stuff. It's really not that hard. And we're going to do stuff to it, like shift it and stretch it and all that stuff. Okay, find the exact value of each function. Well, now you're saying, well, wait a minute, that's not on my unit circle. Well, let's figure out where it would terminate on your unit circle. So it's bigger than 360. Yeah, so we got to just get rid of some 360s because it's just spinning around more than once. So what I want to do is say, all right, grab my calculator, subtract 360, and then realize it's still too big, right? Subtract another 360. So what are we actually doing? We're actually breaking this up into 720 degrees plus, what's left? 135. Okay, now you got down to 135, right? So what it's saying is that since this would terminate with an 135 degree angle, we can say that the sine of 855 is equal to the sine of 135. All right? We're going to just figure out the sine of 135 on our calculator, or not on our calculator, excuse me, in our brains. All right, where's 135? Quadrant 2 with the reference of 45 degrees. Okay, so if this is -1, this would be +1, this would be the square root of 2. You probably already have that one memorized. It's the square root of 2 over 2 once you rationalize it. And the sign is positive in quadrant 2. So it's the square root of 2 over 2. So the sine of 855 degrees is equal to the square root of 2 over 2. Cosine 31 pi over 6. They already did this, but I want to show you, they already showed you what it is, but I'd like to show you why. Okay, so 31 pi over 6. You think about 6. If you have 2 pi and you want to put it into 6, you would need to multiply it top and bottom by 6, which is 12 pi over 6. How many of them did they need to get out of there? What is 4 pi over 6 actually? I mean, not 4 pi over 6, excuse me. If you put 4 pi, you see this is 12 pi over 6, another 12 pi over 6 would be 24 pi over 6. Okay? And that is 4 pi. All right? That's where they got this from. So it's actually 24 pi over 6. 7 pi over 6 plus 24 pi over 6 is 31 pi over 6. Do you understand now where they got that from? Okay, so all they did was say that since that's just twice around, then you can just say, what is the cosine of 7 pi over 6? And they figured out that that's negative square root of 3 over 2. How did they get that? Well, where is 7 pi over 6? 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. 7 pi over 6 is in quadrant 3. Oops. All right, that's a reference to 30 degrees. So where they got that negative square root of 3 over 2 is, the x value is opposite the 60. That would be your negative square root of 3, and this would be -1, and this would be the 2. So if you're thinking about your special right triangles, adjacent over hypotenuse is negative square root of 3 over 2. Or you went on your unit circle and looked it up. But you need to be able to generate them anyway. So why not just keep on thinking special right triangles? That helps. It's better if you get it memorized. All right, so let's do some more examples. We've got negative 510. Has anybody broken that down? Okay, what's that going to be equivalent to? Careful. You're going to have to add 360 again. So do negative 510 plus 720. It's 210, isn't it? Yeah. Okay, so it's going to be equivalent to the sine of 210 degrees. All right, so I'm going to think about where 210 would be. Be quadrant 3. How far into quadrant 3? 180, 210 minus 180 is 30. So you're at 30 reference angle in quadrant 3. Okay, so since I'm in quadrant 3, the sign is going to be negative, and I'm going to figure out what it is. Okay, opposite the 30 would be your -1. This would be negative square root of 3, and this would be 2 if you're doing your special right triangles. So sine is opposite over hypotenuse, so it's -1/2. Otherwise, you got to look it up on your unit circle if you happen to have one in front of you. I think this is faster, but, or I don't know. If you had a unit circle, that would be much faster. Do you want me to remind you how to look it up on the unit circle? All you do is find that angle and look at the second part of the point. Okay, it's -1/2. All right, I'm going to keep doing them without my unit circle. All right, so let's break this one up. Let's get rid of 360. What's left? 5, 3, 135. Okay, so this is going to be equivalent to the cosine of 135. You should have that memorized. 135 terminates in quadrant 2. All students, sine is positive, so cosine here is negative, and all the answers for, not all of the answers, but the cosine and the sine are square root of 2 over 2 for all 45-degree reference angles. Okay. That's a reminder. Okay, 16, we got -5 pi over 2. Oh, that's in terms of that darn pi, so that's in radians. So I got -5 pi over 2. I'm going to add to that 4 pi over 2 because that's got a common denominator, which is 2 pi. But that's not enough, is it? Because that's still going to be negative, so I'm going to do it again. So if I add on another 4 pi over 2, I can tell where I'm terminating. So that's -5 pi over 2 plus 8 pi over 2, which is going to be 3 pi over 2. Where is 3 pi over 2? Well, we should have that memorized, that it's at 270. It's a quadrantal. And that point there is 0, -1. So what's the cosine? 0. The cosine is the x value of that point. Okay. 5 pi over 3. That's on our unit circle, right? 6 pi over 3 would be at 2 pi, so I must be in quadrant 4. See how I'm getting that kind of quick? I'm thinking, if I think about 1 more pi over 3, 6 pi over 3 is 2 pi. So I already know I'm in quadrant 4. Okay, pi over 3 is the 60 degrees, if you want to use that. Otherwise, you should memorize 60 degrees starts off with a 1/2, and square root of 3 over 2 is the second part. In quadrant 4, the sign is negative. So this would be negative square root of 3 over 2. Okay, so I'd like you now to practice, because that's the only way you can get faster at it, is to practice and do more and more of them. You've got your book page printed out. I ran it off and made another worksheet. If you would, please work on that. Otherwise, you can also ask me questions off of 18 or 19 if you'd like. Friday, in 2 days. Unit circle quiz, plus there's going to be some questions on this stuff. Okay? The next quiz, 2 days.